Alright everyone, my name is Jack Tarwater. We are so back for the April video. If you guys don't know, I do a bunch of videos. I do one every month, and they're kind of just about things I'm interested in. Last month was about baseball, and a lot of people really liked that video, so if you like baseball at all, feel free to go check that out. Today's video is going to be a little different. It's going to be a little more on the nerd side of things. We're going back to my roots, just like the first video, which was about deserts, and we're going to be talking about a storm chase that I did. This one, I'm writing with my mouse, this is from April 1st, April Fool's Day. I went on a storm chase with one of my friends. It was a great time. We almost saw what we were looking for, but I'm going to take you step by step through what made me choose April 1st to go chasing, since I can't do every day, and I had to take a day off school, and basically whatnot. So first of all, we have this surface analysis. This is what we call this type of weather map in the weather community. This is at 7 a.m. Eastern Standard Time, or 6 o'clock a.m. Central Time, which is what I am. And you can see a pretty decent setup if you know what we're looking for in severe weather. But if you don't, basically what we're looking for is a lot of temperature. A lot of temperature, a lot of heat, and a lot of moisture, because that's what feeds thunderstorms. And you can see this warm front right here moving upwards means that there's a lot of warm air underneath it. So this whole area is composed of warm air, as it's under the warm front, and the warm front is pushing upward. Behind it, we have this cold front right here, which evidently brings cold air behind it, and that's moving this way, because storms in the northern hemisphere rotate counterclockwise. So what we're looking for here is, again, warmth, and we're looking for higher moisture in the air. And when we're looking for higher moisture, we're looking for what we call a higher dew point temperature, and you can see that in these station models. This is an example of one. So when we're looking at a station model, there's a bunch of different numbers, but really the ones you want to pay attention to are the one on top that says 65. That's the temperature in Fahrenheit, and then below it, right here, is the dew point temperature. That's also in Fahrenheit. And really what we're looking for when we look at the dew point temperature is for it to be as close to the surface temperature as possible. And as the day goes on, they tend to separate because the sun heats up the ground, but it doesn't add moisture. So this is early in the day, so we're going to be looking for very close together dew point temperatures and surface temperatures, and we can see that we have that because this is 66 and this is 64. Right here at this station model, the one below it, 67, 65, but not so much over here because this is 65 and 61. So when we're looking for a moist area, at least at the start of the day, we're kind of looking at a region that looks something like this, and it's inside this area, so like there. And that region is going to be moving along with the rest of the flow from this low level. So it'll move this way vaguely. So since we have moisture here, we expect it to spread upward a little bit into these areas. So this is what we like to call our open warm sector, where we have potential for moisture and warmth. This is a dry line. This just means that the air over here is more moist, and this is not as moist over here, which means we don't even need to look at the weather stations for that. And the open warm sector is where we have a higher tornado threat and a higher hail threat. So let's continue into looking at this. This is the day 2. This is ultimately what made me decide to go, and you can see Lawrence is around here somewhere. Yeah, so it's not too far away. It's a few hundred miles, but that's light work for when you're going storm chasing. You expect to drive a lot of miles. And this is way better than setups that are down here, because then you have to drive easily 1,000 miles. So I'm looking at this enhanced risk for storm chasing. And honestly, I go storm chasing mostly for tornadoes, but I do go occasionally when there's not a tornadic threat. just to take some pictures because I love storm structure and the way that it looks. But here, this was definitely a tornadic setup. We have this large 5% hatched area, or it's not hatched, 5% area. This just means that there's a 5% chance of a tornado happening within 25 miles of a given point in this 5% area. So that's a pretty decent chance. When you're going storm chasing, you can easily cover that kind of distance, and that usually makes for a pretty decent chase, especially over such a wide given area with an interstate system going through it, like here, and even some significant state highways like here going down into Arkansas. Like, this is easy mobility. The road network here is good, so the mobility is pretty decent. We're also looking at a pretty decent wind risk here and a really nice hail risk. This is not somewhere you want to live on this day because of the hail risk. But whatever, I digress. I don't live there, and if there's a storm coming, I can simply drive out of the way. Looking at day one, this is more interesting because it's significantly expanded. We have a much wider area. And then a problem begins to present itself when you're given setups like this. You kind of end up wondering, like, where do you set up shop? Because if I set up shop over here, there's a 0% chance I get over here. So really what you want to do is look for the best possible area to see what you're looking for. And I'm looking for a tornado in this setup. And we have a 10% hatched here, which the percentage, like I said, is, excuse me, the percentage relates to what is the given percent a tornado will happen within 25 miles of a point. So 10% is pretty decent odds. And then this hatched risk means that there's a chance for significant severe weather, which for tornadoes means that EF2 or greater tornadoes, or a decent chance of EF2 or EF2 plus tornadoes. Holy smokes. You can go down and you can see there's a decent area for damaging winds here. And you can also see that there's a pretty decent chance for large hail in a very large region. This is all hatched, which means that you can get a very large hail. I kind of forget what the exact, it's 2 inches or larger, which is, when you're talking about hail, pretty decent. Moving on, this is an observed sounding from earlier in the morning. This is at 12 UTC or 7 a.m. This is about an hour before I left, and I was looking at these photographs, and you can see this adiabatic line here. If you don't know how to read SKUTs, there's a bunch of resources out there. They're called SKU T-graphs. You can look them up. There's plenty of resources online how to read them. But basically what we want is for the area between this dotted line and this red line to be maximized. This is energy stored in the atmosphere. That's what CAPE is, convective available potential energy. And that's what fuels thunderstorms, this energy here. So we're looking to maximize that. This is pretty decent. This is, especially for 7 in the morning, like, this is pretty decent CAPE. The one concern here is this, which is called SIN, convective inhibition. And that's bad. That just prevents storms from starting, or if they do start, it makes them start elevated, and you can't have a tornado in that case. But as the surface warms, you end up eroding your cap, which means that this lessens and you can get surface-based storms as the day progresses. You're also looking here at the dynamics, and you're looking for a photograph generally that looks like this. And you might think this looks similar. This is a bad photograph for tornadoes, but that's fine because that low-level pressure center that I pointed out in the first image here, this low level was fairly weak at the beginning of the day and expected to strengthen, and that would increase these low-level winds, which would make the photograph more curvy, like that. So, anyway, that's kind of what we're looking for here. This is early in the day again, so I didn't let it weigh on me too much, but seeing this much CAPE is a good thing, especially early in this day. This is a quick little upper level chart. This is 500 millibars, so we're looking for a jet stream here, and we can see that there is a jet stream here. But first, let's identify the trough axis. Trough axis is here. That's just where we have an upper level low here, and this is where flow rotates around. You can see these point the direction the wind is blowing. So like this, here it comes around like this, and then up through here. And we're looking for an area of what we call enhanced flow, which is where winds are stronger, and we can see that's the case. This filled in little flag, or the filled in flag on these, means that that's 50 knots plus whatever however tens of many that is. So we can see that there's significant flow, it looks like, through this region, right? And since this is earlier in the day, and since the low is forecast to strengthen, we expect this to move upward over here. And this is going to give us our upper level dynamics. What we're looking for is surface winds blowing this way, and upper level winds blowing this way. We call these veering winds, and that helps us develop mesocyclones, which are the things that spawn tornadoes. This is a little bit later in the day. Excuse me. This is around 1 p.m. Sorry, 11 a.m. I'm still not that great at converting times, but we can see that they've upgraded here to a moderate risk, which when I opened this I was a little surprised about, because it didn't seem like the tornadic risk would increase by that much, but it did increase by that much. The area is much larger than we saw in the prior outlook, which makes forecast areas even more uncertain. But as we scroll down, we see that this moderate risk is hail driven. So this is, yeah, if you see this and you live in that area, you probably want to park your car inside a garage of some kind, your garage, someone else's garage, whatever. Anyway, that didn't concern me too much, because that just means that we need to be on the lookout for hail and not core punch any storms. Moving forward, we can look at the model data. This is also what helped me decide where to storm chase. This is from Convective Chronicles, as you can see in the search bar. I couldn't figure out how to pull up like model data that was archived, so instead we're going to be looking at the model data in a YouTube video from before, and we can see this region of enhanced flow that I was talking about, where the upper level winds at 500 millibars, as seen over here. Oops, I covered it up, but you can see it over here, 500 millibars. And you can see this region of enhanced flow, and what you're looking for is the exit region of the flow, where it starts to diverge. This is the right front exit region. So this helped me narrow it down a little bit when I was looking for tornadoes. I knew that I wanted to be somewhere near this region, and models vary a little bit, so anywhere kind of over here would be fine for that. There's also a debate over the warm front. Tornadoes often spin up along a warm front, which in this image is up here. You can't really see it. But warm fronts they provide a layer for storms to latch onto and become a little more organized. But I've noticed that modes up there tend to be a little more sloppy, because warm fronts can interfere with storms, and they can cause additional convection. That is, I don't know why I drew this in blue. This is supposed to be red. But it can kind of interfere with the way that storms work, and it makes it a lot less certain on what's going on. And you can see down here that there is plenty of moisture occurring, and we don't really need to look anywhere else for tornadoes, because we have this region of high moisture. And again, down here is not the target area. Because the right exit region is not there, so the upper level dynamics don't work out as well in that spot. And we're also looking for the low pressure center, which is up here at this point, because the low pressure center is what's driving all of this. What's driving all of this wind that we're seeing. And the wind blows this way, and so the more north you get, the closer to that low pressure center, the more vertical the winds are going to be, and they're going to be kind of coming out from the side there, which means that the dynamics just don't work as well in this region. So we're shooting for up here, thanks to Convective Chronicles, for recording that video so I can find somewhere to have the model data. We're going to move a little later into the day. This is 18 UTC. 18 UTC is 1 p.m. This is what I was thinking of when I said 1 p.m. earlier. And at 1 p.m. you can see there is no cap. This red line doesn't cross over the dotted line over here, which is really what you're looking for when you're trying to chase tornadoes. Also, this line, the moist adiabatic lapse rate line, there's a massive area here. There's a lot of cape, which is what was forecasted from the start. We knew there was going to be a lot of cape for this setup. It was more about the dynamics in question here. You can see the cape values down here. Surface-based cape is here. Forecast surface-based cape is here. That just forecasts based off the actual temperature. And the most unstable cape is kind of like the optimal scenario for tornadoes. But you can see that this is a really nice setup in terms of convective available potential energy. But over here, the hodograph is not looking the way that we want it to. We're looking for something that is arcing, and this low-level wind here and here doesn't have enough. It's not blowing hard enough at low levels. You need strong southerly low-level winds to produce tornadoes, and it doesn't really look like we have those here. And indeed, if you take a quick glance at the significant tornado parameter down in this box, this is 0, or it's very close to 0, which just means that we're not really seeing any dynamics for tornadoes despite having a lot of energy available. And you can also see here, best guess precipitation type is rain, which means that with this kind of cape, we are going to be seeing rain occurring. But we don't go storm chasing to see rain. I don't know why I closed that. Whatever. This Storm Prediction Center later, 3 hours later, issued this mesoscale discussion, mesoscale discussion number 322 on the year for 2024. We have supercell thunderstorms are expected this afternoon. Threat with these storms include very large hail, strong gusts, and tornadoes. Tornadoes is the big one here that I'm looking for. And so we have this region, kind of. And my idea for the day was to be in Tulsa, because that's kind of the middle ground that I found between the upper level dynamics, moisture, and being farther away from boundaries so that we don't get any interference from more linear modes that would come off maybe a cold front. So I was thinking Tulsa, right there. And it is within the watch zone. The Storm Prediction Center did issue this tornado watch. Tornado watch, based off the mesoscale discussion that they gave out. And Tulsa is well within this area. So I'm like, okay, cool. Tornadoes can definitely be occurring in this zone. This little blue square is a severe thunderstorm watch. And I was waiting in Tulsa, prepared to move down to Oklahoma City or potentially farther south, but I didn't want to go too far because it was a Monday and I had to be back for Tuesday because I had a quiz. But anyway, we were in Tulsa. 30 minutes later, I think that's Tulsa. I could be wrong. I think it's farther this way. This is maybe more Miami area. I don't know. Anyway, you can see this is Kansas, Missouri, Kansas, here, Missouri, to the right. They also issued this, which is a tornado watch will be needed this afternoon, which was, in fact, the case. It says 95% watch probability. A tornado watch was, in fact, issued for this area, and Tulsa's down here, so I probably was right about where Tulsa was. And Oklahoma City's here, and Joplin is here, and I-44 connects all of them up through, I think, Columbia. So things are looking good for me. All of my tornado watch area is well within the area I can get to quickly on I-44. It was just a matter of where off of I-44 was I going to have to go. And the question is, the answer was pretty far, we found. So, oops, I clicked off of that. Another mesoscale discussion was issued at approximately 7 p.m., and we had been driving around trying to figure out where we were going to be based out of. And this kind of connects the areas. Prior to this, let's draw it with the blue. There's a tornado watch here and a tornado watch here, but this kind of severe thunderstorm watch in this area was less clear, and they finally did it. They finally issued a tornado watch there, or not issued a tornado watch, but they definitely revised their wording on this to show that tornadoes were definitely possible in the southeast corner of Kansas, and that's where we ended up waiting. We ended up waiting in Coffeyville, Kansas, and just at a gas station there. I don't remember if it was a Quick Trip or whatever, but we were there. And you guys will see how that worked out for us. First things first, let's see. Where is this? Oh, this is the circulation. So I thought I had another weather radar up, but I guess I didn't. You can kind of see there's precipitation down in the bottom left of this mesoscale discussion that I'm circling right now. That generally tends to like interfere with, it wasn't mesocyclonic at all. There was no rotation, which is what you need for tornadoes, and you can't usually count on them to, you can't count on storms to become tornadic or mesocyclonic if they're just broad showers, which they are in this. We had, and also here, you can see that there's kind of these like broad showers down here, and none of them are really like storms. They're kind of just a little bit of rain, right? But you can't see this. These are definitely storms, and they were mesocyclonic. They did have rotation on them, but they were relatively broad. And the rotation continued weakening as it moved out of this area, so just west of Tulsa. And as they were moving up towards Coffeyville, which is where we were located, they just got weaker and weaker. And I'm not sure why, but I definitely discounted this storm moving northward. And that turned out to be the right call, as the rotation weakened enough to basically not even be rotation on radar, right around Pittsburgh, Kansas. So we just chilled in Coffeyville after we were observing those storms from afar on radar, and I realized that they weren't really, it wasn't really the target for us. And that was maybe a good thing. This is Tulsa down here in the bottom right. We have Winona here and Bartlesville north of Tulsa, kind of this triangle. And if we go back, you can see this triangle is here, right? And we're in Coffeyville. So keep in mind where that is. We're kind of just zooming in on this top part of Oklahoma. The Kansas border is probably towards the edge of my screen over here. But anyway, this rotation picked up. You can see green is inbound, red is outbound. So right in this spot on this black line I just drew, there's rotation where the arrow is, that's a terrible vector, where you can see that the wind is moving kind of that way and kind of this way. And in the middle, there's rotation there. It's pretty broad in this. You would not expect a tornado to drop from this. And you can also see a similar phenomenon. The radar station is down here, I believe. So you can see outbounds here and inbounds here, which means that there's rotation, counterclockwise rotation also happening here, as well as up here. And this is a band of storms that was coming through. I'll show you the base reflectivity here. Yeah, this is a pretty decent set of storms, and we're looking at it, and I was kind of hesitant, but they're all moving this way. And if you remember from before, Coffeyville, Kansas these storms were vaguely right here. They're moving up towards Coffeyville, so we were comfortable waiting there for these circulations to come to us, because they were pretty broad, and they did not look like they were going to be dropping a tornado anytime soon. That did change, however. This rapidly strengthened, passed through Winona, Oklahoma, and when it did, it picked up. It first strengthened a crazy amount. As it passed just south of Winona here, it picked up a lot of debris from the ground, and we can see that on radar. This radar archive product doesn't have correlation coefficient, but it's picked up a bunch of debris, and you can see that on radar if you know what you're looking for. So there was a confirmed tornado on the ground here, and we were up in Coffeyville, Kansas, and the storms are moving roughly this way. Sorry, they're actually moving more this way. And we're in Coffeeville, and these storms were moving fast, but not that fast. So I figured, we could probably get to the circulation before it weakens too much, or before right as it passes by Bartlesville. Like, we'll meet it here or in Bartlesville, I was thinking. So the move for that is to drive south through Lenape and to Nowata, and then drive west from there. That's the quickest way. That's what my map told me was the quickest way, so I believed it. Right? This is the reflectivity product of this scan, and you can see down by where this rotation is. I'm going to circle it here in blue. You can see where this rotation is. Can I? I'm figuring out how to use this. Yeah, so you can see that this corresponds nicely with this little hook echo that we're seeing. And that means that the storm is drawing an inflow here, which is creating rotation as this pushes outward, which is what you expect to see in a tornado. And this debris, this is not necessarily a debris signature, but it is definitely a rear flank downdraft where air is coming out of the storm and dropping large precipitation. That's why we see these little white dots. These little white dots also could be debris from a tornado. It seems unlikely, though. It's not a tight enough signature for that. So let's continue. You can see that the rotation is keeping up right here. By this point, my car is approximately located here. And so we're on track to make this circulation. We're on track to see it. It is dark by this point, and there is a lot of lightning coming out of here. You can also see there's kind of maybe a circulation up here, but that appears to be corrupted radar data. And the other circulation is a little bit petered out down south. So it's a good thing we chose the one that we did. As we proceed, we can see that this circulation didn't move that much. The circulation is actually located right here. It's a little harder to see because it's broadened significantly, which means that there is no tornado on the ground for sure here. It's just not enough. The radar station is located down here, I believe, which means that this is outbound, this is inbound, and there is rotation, but it's just not significant here, which is a bummer for us because at this moment, my car was located right here. And looking, you can hear the people outside, looking into the storm from this angle, we actually saw the circulation pass over our heads. I thought it was a tornado because the wall cloud was very significant at this point, and it was hard to see because it was a little bit rain wrapped. I'll actually show you that as well. If we go to the radar product, we can look at base reflectivity, and you can see that there's a lot of rain around where the storm is, and on the other side, as well as over here. And over here, it's just not a very clean mode. And I saw heavy rotation come through, move. It wasn't obviously right over our head, but it was close to our head. It was maybe a mile, less than a mile west of us, which is a bummer that there wasn't a tornado on the ground right there. But since we weren't in any town or anything, and you can see right after it passed over us, it re-strengthened again, tightened back up. We have strong outbounds and slightly less strong inbounds, but it doesn't really matter as long as one of them is strong and the rotation is tight. You can see that there is a couple pixels here where it looks really tight. And at this point, we were in Nowata. I was looking at this and looking at the reflectivity here, and I was like, man, we might be able to make it up to Delaware. Delaware is roughly halfway in between, like here maybe. We could probably make it to Delaware, and if there's a tornado on the ground, we'd be able to see it. But I didn't feel comfortable trying to race this storm northward as it was coming this way and not really have a way out because these rear flank downdrafts can carry big hail. And I don't want to get a tornado dropped on my head, and I don't want hail smashing my window of a car that I don't even own. It's my parents' car that I just get to use all the time. So I ended up not making that call because my storm chasing buddy doesn't know a lot about the weather. He just knows where to go when I tell him and what he wants to see. And you can see that this is in fact the case. There was a big rotation here, and we would not have made it up in time. I checked the radar, synced it up with where we were. You can kind of see all of this transpiring here. with this being Coffeyville, this being Bartlesville, this being Nowata, Delaware, and Lenape. You can see we were in the Phillips 66 at Coffeyville. We were there at 7:30, according to my Google timeline. We were there at 7:23 is when we dipped south. We made it to Nowata. We didn't stop, so we don't get a timestamp on that, but it was somewhere around 7:50-ish, and we were right here, and the circulation passed right here, which is a bummer that it picked up the tornado right as we were passing over. And from here, we drove to Veneta, Oklahoma, because we figured that was our best move. We could go north from here, or we could drop back down closer to where the storms were originating down here. But we opted not to do that. I checked all of the stuff that we had. It looked like there was a lot of very messy convection. Let's actually see. We can go to the reflectivity here, and we can zoom out just a little bit. Let's see if it'll let us free zoom. Yeah, you can kind of see that there's very sloppy mode here. Just a lot of storms. None of these down here had significant rotation other than the cell that we were on right here. And just a lot of like free cells floating in the broader convection going on. And those just don't usually strengthen up enough to become tornadoes. So I figured we would call it there. And that was the right choice, because if we look at this, we can see that there were only a few confirmed tornado reports over in the area we were at all, which is here again. There was one here, and there were a few here, but this is an hour or two away, so there was no chance we would have been able to see both of those. And this was the longest track tornado of the day within reach. I could have gone over here, but that just wasn't happening since I live in Lawrence. That's a multi-hour drive, 5+ hours. So it's much better to stick to local stuff. This is what we got. And basically, I'm very happy with my forecasting performance for the day, because it ended us up right where we needed to be if we were going to see a tornado. And we can see the damage assessment toolkit here. This is a map of all of the tornadoes on a given day. You can see all of this stuff over by Illinois and Indiana. And Oklahoma is right here. So if we look at northeast Oklahoma, you can see the tornadoes that dropped on us. And again, if we look at Bartlesville, Tulsa, and Winona, which I don't think Winona is on this map, but it is like right there, I think. Oh well, irrelevant. You kind of get the sense of scale anyway. This is the tornado that was confirmed by Winona that picked up debris. You can see that it was given an EF1 intensity here, here, and at these damage indicators. You can see that the tornado dropped just south of Bartlesville on the highway, which if we were a little bit quicker on the draw, we maybe could have made it there, but odds are not great. This is the same circulation, by the way. It traveled up this way. And we were right here watching the circulation pass from there to here, which is a bummer. That we didn't get to see anything interesting, but it is what it is. And you can see that this tornado did in fact come back down very close to Delaware. If we had been in Delaware, we maybe would have seen one. We maybe would not have, because it was dark outside and there was no lightning, and also we might have set up shop just south of Delaware. But I think we would have got wrecked by hail anyway, so I'm very happy that we did not go up that way. Especially because we would have been core punching, because the reflectivity at this point was probably like this, and we would have had to drive through a small hail core right here, which, you know, it just is what it is. And this is not a tornado. This is just thunderstorm damage. So is this. And we were all the way over here. We ended up by Veneta, and there just wasn't another opportunity for us to storm chase that night, despite the Storm Prediction Center issuing another mesoscale discussion at 9 p.m. saying that tornado potential was high. That was not realized, so we went ahead and we drove home from there, up here, and then back to Lawrence, which is where I live. So Overall, very interesting experience. Very nice storm chase from me and my forecasting ability, because there were not that many tornadoes in the 10 hatched region. You can see there's not that much in the 10 hatched region. So I'm happy with my forecasting because it took me to Tulsa, which is very close to where tornadic conditions ended up being. Yeah, so overall good forecasting from me. It would have been maybe a little better to find somewhere with Wi-Fi to sit and wait, because not Wi-Fi, cell service, because I didn't have cell service, but my friend did, and it wasn't that fast, so I was getting radar updates really slowly. If we had been on that circulation a little sooner, been a little more decisive, we definitely could have seen that tornado. I did get a couple pictures of just thunderstorms off in the distance, like farther over here. When we were sitting here, I took them with just my camera, and they're pretty neat, but they won't go up on my Instagram account because I didn't take enough of them for a full post. So it is what it is. And I also learned that nocturnal storm chasing sucks and is very difficult, and I should avoid it if possible, which is a little bit of a bummer because this Thursday, Friday, I'm recording this on 4/20. This Thursday, Friday, there's a storm chasing event, and I get out of class at 6 on Thursday, and at I guess 2 on Friday would be doable. The risk area is vaguely over here, so we might be storm chasing again. However, there will not be a storm chasing video again for a little while. Even if I make a storm chasing video, it'll come out in August or September because of just the way that things are lined up. I'm doing a history of KU video. I don't know why I'm writing this out. History of KU. That's just for May. I have to edit that, or I have to record that, write the script, edit everything before May 10th, because on May 10th I'm going on a massive trip. I'm not going to tell where I'm going, even though it's probably fine if I do. I'm going vaguely through the American Southwest back to my home that's vaguely over here. So the history of KU video will come out 3 days after I'm off the road. It's going to be a long road trip, like 18 days. And then my May video is going to be history of KU. June is going to be Oakland baseball. I think. No. The June video is going to be about my May trip, because I need time to go through all the footage. I can't edit all that footage in 3 days and like create a narrative out of it in 3 days. So that's going to come out at the end of June. In June, I'm going to Oakland. So the July video will be a recap of Oakland baseball. In July, I'm going to Hawaii. So since July is going to be about Oakland, then August is going to be about Hawaii. I'm going to do a volcanoes video since I'm a geology nerd as well. And then in September, we'll see. September, I would like to do like a little house tour video because I'm getting a college house. So I think that would be fun. But we'll see in September what happens. But I have the next like 4 months of videos laid out, which means that if I film a storm chasing video, it'll come out probably after all of those, unless the KU video ends up sucking. And I realize that while I'm making it, and I have a storm chasing video lined up, and that'll come out instead. But it should be a fun couple of videos coming up. Thanks for watching. I really appreciate it. Go check out my other monthly videos. Subscribe if you want to stay tuned. See me romp around the desert and the mountains for a little while, or explain Oakland baseball, or any of that stuff. I really appreciate it. Bye.